Hello, it's me again. Good morning. Let my loud, melodious voice wake all of you up because we got coffee for another hour still. So I have the honor of introducing Tetsuya Amano, who will have a plenary this morning titled Language Barriers in Science, Consequences and Solution. Tetsuya is a senior lecturer at the School of Environment and Center for Biodiversity and Conservation Science at the University of Queensland. He received his PhD at the University of Tokyo in 2006, after which he worked for the National Institute for Agro-Environmental Sciences in Japan for 5 years. After that, he had a Marie Curie Fellowship at Cambridge in the zoology department, and then a research associate at what I think is my favorite center name ever, the Center for the Study of Existential Risk, that's ominous, in Cambridge, where he focused on the effective use of scientific information for biodiversity conservation. And then in 2019, he joined his current position, that's in Queensland. He also founded the Kaisen Conservation Group, which is seeking to improve the conservation using interdisciplinary approaches in both research and the decisions made from this research. As well, Tetsuya has been leading the Translate project, which stands for Transcending Language Barriers to Environmental Sciences, looking at how language barriers can impede evidence-based biodiversity conservation. So he will tell you more about that later. And just 2 days ago, he won the British Ecological Society Equality and Diversity Champion Award. So congratulations. So it's my honor to introduce Tetsuya. Thank you.
Great. Thanks so much. Thanks so much for the kind introduction, and thanks to the organizers. It is my absolute pleasure to be able to give this presentation for this really great and fascinating meeting. So I will be talking about language barriers in science. And about 9 years ago, when I was studying my postdoc in Cambridge, I started working on language barriers in science, especially in biodiversity conservation. And then about 6 years ago, when I moved to Australia, I launched this project called the Translate Project, which is trying to understand consequences of language barriers in science, especially in environmental sciences. So my background is biodiversity conservation, so not animal behavior. So my project has been focusing largely on this specific discipline. But hopefully, many of the findings from our project are applicable to almost any discipline in science and even STEM field. So I hope you will enjoy my talk today. So I will give a brief overview of what language barriers in science are and what consequences language barriers might have in science and how we can tackle this challenge. Okay, but before moving on to actual presentation, let me briefly explain my relationship with the study of animal behavior. So because I started my career as a behavioral ecologist, so no one knows this actually, but I worked on the foraging ecology of this species, white-fronted geese in Japan. So I did a lot of field work. And then I became deeply interested in this application of behavioral ecology to biodiversity conservation, largely influenced by this paper written by Bill Sutherland in Cambridge. So he's now my long-term collaborator and mentor. But anyway, this paper is actually published in none other than Animal Behavior. So it's really fascinating for me to be able to be here to give this presentation. But I would never have imagined that 20 years ago, having started my career as a behavioral ecologist, I would be giving my talk about language barriers and science, not about animal behavior. So it's a very interesting trajectory as a scientist. So anyway, why am I going to be talking about language barriers in science? Let me start by asking this question. How many languages are there in the world? Has anyone got any idea? Maybe it's a bit quiet, but there are over 7,000 languages in the world. So there are lots of languages, so many languages. And even in Australia alone, there are over 300 languages. So it's a big hotspot of language diversity. So the next question is, how many native English speakers are there in the world? I wouldn't expect you to answer this question, but it's 380 million people, so it's a lot of people. However, when calculating the proportion, 95% of the world populations are actually non-native English speakers. So majority of people are non-native English speakers. And it is those people who practice science of any discipline. And those people use 7,000 languages to communicate. So why would we not take language into account when talking about science? To me, it only seems natural and absolutely necessary to consider how having so many languages among us might influence the way we do science. Let's also look at these two maps. The map on the left shows the states and territories where English is an official language, and the map on the right is the species distribution. So do you think these two maps are different or similar? I believe here we have two very contrasting maps. So the regions where biodiversity is the richest, threatened the most, and therefore conservation and research is needed the most, are often regions where English is not widely spoken. So there is a really close correlation between the species distribution and language distribution. Let's also look at this study nicely led by our former postdoc, Pablo Nigret. In this paper, we looked at how many official languages are spoken within the distribution range of each of the 10,000 bird species in the world. For example, this is common pochard, with a huge geographical range spanning across the Eurasian continent. And as a result, a total of 74 official languages are spoken within its distribution range of this single species. And importantly, we found that over 1,500 species had 10 or even more languages spoken within their distribution range, and over 8,000 with 2 or more species, so with 2 or more official languages. So this clearly indicates that we need to understand the consequences of having so many languages spoken within the distribution range of each of those species for studying those species and conserving those species. And that is exactly why our Translate project has been trying to understand the many consequences of language barriers in science, especially in biodiversity conservation. So more specifically, this paper published in 2016, we showed that over 1/3 of conservation-related scientific documents seem to be written in languages other than English. But this non-English language literature is likely underused in the global level synthesis of scientific evidence because it's not readily accessible to many people. So this is language barrier to the synthesis of scientific evidence. Then there's another type of language barrier where scientific evidence that is available only in English may not be effectively being used in local decision-making, such as policy-making in countries where English is not widely spoken. So this is language barrier to the application of scientific evidence. Then, obviously, due to language barriers, many non-native English speakers may not be able to fully contribute to the generation of scientific evidence. So this is another type of language barrier. So we have been working on these 3 types of language barriers, but I believe these 2 types are especially relevant to the study of animal behavior. So my talk today will focus on these 2 types, and then I will introduce some of our recent work on these 2 types of language barriers in science. So let's start with the generation of scientific evidence. So because science is now largely conducted in English, especially at the international level, many non-native English speakers can face multiple barriers when conducting different types of scientific activities, such as paper reading, paper writing, paper publication, and research dissemination. So we tried to quantify these barriers by comparing the amount of effort needed to conduct different scientific activities in English between non-native and native English speakers. For this, we surveyed 908 environmental scientists with 8 different nationalities. So we chose these 8 countries based on their English proficiency and income level so that we can compare results between individuals with different linguistic and economic backgrounds. And what we found was actually truly striking. So this is a comparison between non-native and native English speakers with only one publication. So this is essentially for comparison for early career researchers. But based on our study, non-native English speakers need 91% more time to read every single paper in English compared to native English speakers. So their hurdle is twice as high as that of native English speakers. Then they also need 51% more time to write every single paper in English. And then before they submit those papers to journals, they also ask someone, either professional or amateur, to proofread their English for most of their papers, and this is really time-consuming process. Even then, their papers are more likely to get rejected, unfortunately, by academic journals, and its frequency is 2.6 times higher than that of native English speakers. And then there's a huge hurdle for paper revisions. I can't really fit it in here, but non-native English speakers are requested to revise their papers simply due to English writing 12 times more often than native English speakers, so it's a big hurdle. For presentation, they need 94% more time to prepare and practice their English presentation. So I'm now smoothly delivering this presentation, but this is all thanks to the amount of time I spent for the practice of my presentation. Sorry, I'm just kidding, sorry. And yeah, what's more, 30% of them often decide not to attend the international conference because they are not confident in English communication. And half of them often decide not to give an oral presentation, again, due to the language barriers. And what's really important here is this is not the end of the race. Because as long as you are in a research career, you need to face and overcome these barriers, these hurdles, every time you do any of these scientific activities. So now it's crystal clear that these disadvantages can severely impede the fair participation in and full contribution to science by non-native English speakers, having serious consequences for their career development. We are also seeing some other evidence, so this is not our study, but some other evidence that shows the same type of language barriers in science. So here there are 2 English sentences with exactly the same content, same meaning, but with a slightly different writing style. So maybe you can spend a bit of time and then maybe think about which might be native-like English. And the answer is, this is the native language. The one on the left is native-like English. But as you can see, the difference is so subtle, so there might be some grammatical errors in the sentence on the right. But what's really important here is you can completely understand the meaning even with the sentence on the right, non-native-like English. But unfortunately, the science written in this way is rated lower based on this study using the randomized control trial. So this is really robust evidence. Language barriers can also cause an increased level of dissatisfaction, anxiety, and imposter syndrome. And language barriers can also impede the effective management and development of international collaboration, understandably. So the consequences of language barriers for non-native English speakers is huge. So these language barriers, together with the impact of other types of disparities, can have serious consequences for the apparent productivity of non-native English speakers. For example, using the data from the same survey with 908 environmental scientists, we showed that female researchers published statistically significantly fewer number of English language papers than male researchers. Similarly, non-native English speakers publish a fewer number of English language papers than native English speakers. And those from lower income countries also publish a fewer number of English language papers than those from higher income countries. So these three factors can hugely influence the apparent productivity of individual scientists. And of course, we as scientists all know that correlation does not necessarily indicate causation. But when we used the number of English language and non-English language publications combined, there was actually no significant difference in the apparent productivity between native and non-native English speakers, as you can see in this figure. So this gives us a really strong signal that the need to write those papers in a language that is not your first language is actually leading to a fewer number of English language papers from those non-native English speakers. So given all these results, you might imagine how the impact of these different disparities might accumulate for certain groups of people. So this figure shows the percentage difference in the number of English language papers published by individuals with different attributes. So the reference is here in pink, which is male native English speakers from high-income countries. So being a female researcher, scientist alone can be associated with up to a 45% reduction in the number of English language publications. So it's a massive productivity gap. And then if you are female and a non-native English speaker, the number of your English language publications can be up to 60% fewer than that of male native English speakers. And then if you're female, non-native English speaker, and from lower middle income country, the number of your English language publications can be up to 70% fewer than that of male native English speaker from high income countries. And needless to say, the number of English language publications is still widely used as a performance measure for when assessing scientists. But it's clearly unfair to use this measure, and we need to explicitly consider the impact of these different types of disparities when assessing scientists and their science. Okay, so now let's move on to another type of language barriers, which is language barriers to the synthesis of scientific evidence. So evidence synthesis, such as systematic literature reviews or meta-analysis, is becoming increasingly important in both basic and applied science. And I was not sure how commonly it is used in the study of animal behavior, so I have quickly searched for systematic literature reviews and meta-analysis in the journal Animal Behavior. And then I found at least four meta-analysis systematic reviews were published only in 2024 alone. So I believe this is also important in this discipline. So how is non-English language science evidence used in the global level evidence synthesis? In this paper, nicely led by our PhD student, Kelsey Hanna, we looked at the use of non-English language literature in all the systematic literature reviews and maps published in this journal, Environmental Evidence. So this journal is specifically targeted at publishing systematic literature reviews and maps in environmental sciences. And we found that only 38% of those reviews proactively searched for relevant studies and in at least one non-English language. And even among these 38%, most of the languages searched were of European origin. And for example, no Asian languages were searched, although many of those reviews had a global focus. So this clearly indicates that most of the existing scientific evidence published in non-English languages is not effectively used in the global level evidence synthesis. So what are the consequences of ignoring such non-English language science? First, we could be losing access to a non-negligible amount of scientific evidence. So quite often, many people now assume that non-English language studies must be diminishing as science is becoming increasingly globalized. But in this study led by Sean Chaudhry, we showed that the number of conservation-related articles published every year has been rapidly increasing in most languages such as Spanish, Portuguese, simplified Chinese, Russian, and so on, almost any non-English languages. So contrary to the common perception, the importance of non-English language studies is not diminishing, at least in this area of conservation science. But of course, the importance of non-English language literature can vary greatly between topics and disciplines. For example, these are some studies that compared the availability of scientific evidence between English and non-English languages. And as you can see, it varies a lot. But at the same time, we can also see that there is a non-negligible amount of scientific evidence available in non-English languages for a wide range of topics, such as economic cost of invasive species, thermal tolerance of amphibians, to urban ecosystem services in Russia, and so on. So we could be losing access to this amount of scientific evidence by ignoring non-English language evidence. So what about the study of animal behavior? Actually, one of the 4 meta-analyses I found published in Animal Behavior in 2024 searched for studies in English and in simplified Chinese. And 2 out of the 14 eligible studies were actually written in Chinese languages. So apparently the importance of non-English language literature seems to be applicable to this study of animal behavior as well. And the second, ignoring non-English language literature can also cause severe bias in our understanding of a phenomena. So in the research area of healthcare, it has been shown that statistically significant and more positive results are more likely to get published in English. So this is known as language bias in evidence synthesis, and more specifically, language bias in statistical results, meaning that the nature and direction of a study's results can influence the language of its publication. And we showed that this type of bias does exist in ecology and conservation. For example, here, the effect size was hugely different between English language studies and Japanese language studies. And obviously, in this case, ignoring non-English language studies, in this case, Japanese language studies, can hugely bias the conclusion of this meta-analysis. But in ecology and conservation, there might be another type of language bias, which is language bias in study characteristics. For example, studies conducted on a local species might be more likely to get published in non-English language journals because those studies would not be of high interest to international readers. And in this study, we showed that this type of language bias does exist, having serious consequences for conservation. Here, these blue grid cells show the study location of English language studies testing the effectiveness of conservation interventions stored in this conservation evidence database. So it's a global database. And as you can see, these English language studies are hugely concentrated in certain countries, such as the UK and the US. And there's a huge gap in the availability of scientific evidence, English language evidence, in other parts of the world, especially in biodiverse regions such as Latin America, Africa, Russia, and most of the Asian countries. And when we searched for relevant studies in other languages using exactly the same selection criteria, we found a number of important studies published in a total of 15 different languages, exactly in those regions with little or even no English language evidence, such as Latin America, part of Africa, Russia, and especially East Asian countries. And this is not only about location, it's also about species. So this figure shows the number of studies testing the effectiveness of intervention for each species. So these blue bars indicate the number of English language studies for each species. For example, the bird species with the highest number of English language studies is skylark, with 44 English language studies here, testing the effectiveness of intervention for this particular species. But what's really important here is these red bars showing the number of non-English language studies for those species without any English language evidence. So we have 270 bird species like that, including this endangered brachyson-fish owls in Japan, published in a Japanese language study, and 64 mammal species like this endangered Andean mountain cat in northern Patagonia, published in a Spanish language study. So there is a clear and systematic bias in the study location and the study species between English and non-English language studies. And by ignoring non-English language studies, we could be losing access to this really important source of scientific evidence, especially for those areas and for those species with little or even no English language evidence. Okay, so now that hopefully I have shown you why it is important to think about language barriers in science, the question is how we can solve this issue. And I'll say it's not easy at all, so we need a concerted effort from every single level, like individuals, institutions, journals, funders, conferences, and so on. But many people have actually already proposed a number of potential solutions to different types of language barriers in science. So recently, we have compiled all these solutions from a total of 21 different studies to create this huge checklist of actions to solve language barriers in science. And this paper is to be published next year, so hopefully you can see it in the next year. And these, I won't go into the detail of every single action, but these solutions, these actions can be largely categorized into 3 different groups, which is addressing language disparities, promoting linguistic diversity, and multilingualizing science and its communication. So I will show you some examples in this presentation. Okay, so first, distinguish the quality of science from the quality of language. So this is an editorial decision letter we have recently received, unfortunately, from on a paper which I was involved as a co-author, and also led by a student whose first language is not English. So let me briefly read the letter. Dear authors, thank you for submitting your manuscript to this journal. After careful evaluation, I regret to inform you that the level of English throughout your manuscript does not meet the journal's required standard, and I must therefore reject it. For help with English language usage and quality, we strongly recommend you consult a professional language editing service. Please visit our customer service, blah, blah, blah. So can you see where the problem here is? I can see at least 2 major problems here. First, this editor has not looked at the quality of science, not at all. All they say is the quality of English was not good enough, and therefore they reject it, unfortunately. And I'm also serving as an editor for many other journals, I mean, not many, but several journals. So I can completely understand that if the quality of English is truly, not very good, it can be really hard to assess the quality of science. That is definitely true. But for this particular paper, I can tell you that the quality of English was good enough because I also looked at this paper. I read this paper. So the assessment should be able to be possible. However, this editor has not done that. So where the second problem is? The second problem is this blanket transfer to a professional language editing service. So why is that the problem? Because it's not for free. And it can be highly costly. This is just one example. Obviously, depending on how you are in a hurry, you need to pay more, obviously. But anyway, in this study, we showed that many people, especially those from lower income countries, can't afford to use such paid English editing service, presumably because of the lack of funding. So those people can be disproportionately disadvantaged, influenced by these editorial decisions in academic journals. So that is a huge problem. And unfortunately, our paper is not an exception. So in this research led by Henry Arenas Castro, we surveyed 736 journals in biological sciences, and we found that most of the journals do not provide genuine support for non-native English speakers. For example, for English editing support, 41% of those journals provide no English editing support, whereas 58% simply direct authors to commercial services, just like that journal. So this is not genuine support, obviously. And 6% and 4% each have instructions, guidelines for authors, reviewers and editors to tell them to explicitly distinguish the quality of science from the quality of language. So it's a really small proportion. So those papers, those journals not necessarily provide genuine support, and this is something we immediately need to change in academia. Next, take into account disadvantages for non-native English speakers. So as we showed in this study, there's a huge productivity gap, apparent productivity gap between different individuals with different types of disparities, like gender, linguistic, and economic backgrounds. So it is clearly unfair to use the number of English language publications when assessing scientists. But this is still happening. So one easy step you can take for non-native English speakers might be using the number of non-English language papers when assessing scientists. Because when we combined the number of English and non-English language papers together, the productivity gap still exists. So this is important, but it clearly narrows, it diminishes. So this might help. And I'm sure there must be so many other solutions to take into account those disadvantages. So we definitely need to think about it and then implement those solutions to do so. Next, involving culturally and linguistically diverse people in your team can form a fundamental basis for breaking language barriers to the synthesis of scientific evidence. For example, in this study, collaborating with over 50 different people from around the world actually allowed us to search for relevant studies for this study in a total of 15 different languages. And indeed, it works. So in this study, we showed that a systematic literature review by authors with more linguistically diverse background actually searched for relevant studies in more non-English languages. So there's a clear correlation between the number of languages spoken by the team and the number of languages searched. And because science is now highly globalized, so it is not that difficult to find native speakers of, say, Spanish, Portuguese, simplified Chinese, French, and so on. So what I want to ask you is, does anyone speak Spanish? No? Oh, there might be someone. Yeah, that's good. Yeah. Does anyone speak Portuguese? Oh, that's good. That's much better. Not better, but does anyone speak French? Oh, lots of people. That's good. How about simplified Chinese? That's good. Yeah, lots of people. Okay, so this clearly indicates, the importance of developing culturally diverse environments in academia. We need a diverse range of people to make the best use of scientific evidence available from around the world. So yeah, I forgot to ask about Dutch. So sorry about that. Yeah, I was talking to someone from the Netherlands. Anyway, so how about journal editors? So Elsevier now provides really useful information on the editorial board in different countries, by country. So I've quickly looked at animal behavior. So there are apparently 45 editors in 15 different countries, regions, so which looks good. But if you look at the detail, 60% of them are from those two countries. And obviously, in a sense, this is understandable. So apparently, this journal is published for the two societies in those two countries. But there might be something for you to consider. So why is having diverse editors in academic journals important? I'm sure there must be so many reasons for this, but this might be one reason. So there is a huge, severe geographical bias in the number of submitted and accepted papers in most journals, as you can see in this example of the Journal of Applied Ecology. And having a culturally and linguistically diverse editors might help us to rectify such geographical barriers. And of course, I'm sure you know that studies on female bird songs tend to be authored by female researchers, showing the importance of diversity among researchers, scientists in scientific innovation. And I strongly believe this is also applicable to the cultural and linguistic diversity of researchers. So the most common question I seem to get recently when I talk about language barriers in science is whether AI helps or not. So I will explain that beforehand. So as we all know, many AI tools have recently emerged, and these AI tools can provide really useful support as we try to tackle these different types of language barriers in science. However, the rise of these AI tools has actually created some new issues, especially in terms of inequality in science. For example, the performance of these AI tools can vary greatly between languages. As you might remember, there are over 7,000 languages in the world, and these over 2,000 languages spoken by a total of 1.2 billion people have almost no digital resources. So these languages can be completely left out in the age of AI development. And meanwhile, only these 7 languages, including English and some other large languages, have huge amount of digital resources. So these languages can massively benefit from the development of AI technologies. So the development of these AI technologies may not solve the fundamental issue of language barriers in science, but it may only shift the disparity from between native English speakers and non-native English speakers to between speakers of resource-rich languages and the speakers of resource-poor languages. So it may not solve the fundamental problem. Secondly, many AI tools, especially those of higher quality, are not for free, unfortunately. And this is another big problem. So last year, we were excited to see this press release from the Springer Nature, which says, global research shows that it takes non-native English speaker scientists 51% more time to write a paper. Sounds familiar. And citing our paper, which is really good. And then they continued, like, Curie is our response. It's promising, isn't it? We published a paper, and then there's an immediate response from a really big publisher providing a link to this AI English editing service. So we were excited, and then clicked the link, and then we were told to choose the plan. Yeah? So it's not for free. Of course, these are much, much more affordable compared to human translators and English editors. But still, this might give rise to another inequality issue where those from higher income countries and more privileged researchers with, like those with more funding would be more likely to leverage those AI tools, which might even widen the existing inequality in science. And thirdly, many non-native English speakers may face a new type of discrimination in terms of the use of AI tools. For example, last year, the journal Science has declared that they will completely ban the use of text generated by ChatGPT and any other AI tools for their papers. But as I said, these tools provide really useful and important support for non-native English speakers. So we immediately wrote a letter in this initiative led by Violeta Verdejo Espinola, and we explained that the use of these AI tools can help us to achieve better equity if properly used by reducing language barriers in science. And the good news is, in response to our letter, hopefully, they have changed and loosened their policy to now allow authors to use large language models to proofread their English manuscript with some proper disclosure. So this was great news, but clearly their initial decision represent a really biased and native English speaker oriented view of the use of AI tools and this issue of language barriers in science. And we are also seeing some other evidence that shows the use of AI English editing services can be flagged as AI-generated text by some of the AI detectors, as you might know. So this also results in many non-native English speakers facing a new type of inequality issues in academia. So in sum, I would definitely say those AI tools are really promising and can provide very useful support as we try to overcome different types of language barriers, and we are also working on it. But we still need to carefully understand its impact on science and society, and especially in terms of the new types of inequality issue that it may give rise to in academia. Okay, so lastly, let me also highlight one of our recent initiatives related to conferences, where we are seriously trying to reduce language barriers for non-native English speakers. So this is the ICCB 2025. This is the largest conservation conference to be held in Brisbane, our city, next year, next June. And here we are seriously trying to reduce language barriers for conference participants to promote the participation of culturally and linguistically diverse people from around the world. So how did we start? We started by clarifying our philosophy. So from day one, we shared the philosophy of linguistic inclusivity within the steering committee to make this consensus. And then we also declared this philosophy by publishing it on the website almost 2 years before the conference in multiple languages. And we then organized a brainstorming session with 13 people with highly diverse backgrounds to discuss what types of support we might be able to provide at this conference. And then based on the ideas from the session, we conducted a global survey to understand which type of support are most needed by potential participants from around the world. So a total of 475 people with 45 nationalities participated in this survey, and the results are already publicly available on the conference website. Because we also needed some potential sponsors, so we started contacting potential sponsors almost 1 year before the conference. And then we officially launched the Language Accessibility Subcommittee with 6 different members. Since then, we have been implementing some of the exciting initiatives to support non-native English speakers. For example, we made machine translation accessible on the conference website. And obviously, machine translation is not perfect, and it's not available for many languages, but I believe this still helps many people. And thanks to the sponsor from Rightful, we were able to free AI English editing support for anyone who is submitting abstracts. So if you are submitting abstract, you can use this service. We have also established linguistically inclusive review guidelines, including this no rejection for poor language policy. So all reviewers are requested to follow these guidelines when assessing abstracts and symposia proposals. We also offered an option for non-English oral presentation, although this is still subject to the number of people who prefer this option. We have also discussed with the conference venue and make sure that presenter view is available to any presenter. Because it is quite often for non-native English speakers to see some text in this present view, so it's now available here. So it's really easy to do this presentation. But because this helps for non-native speakers. So we made sure it's always available in every single room. We also plan to offer a mentorship program for non-native English speakers in preparing and practicing English language presentations. And we have recently started recruiting potential mentors for this. So we are still working on some other exciting initiatives, and our ultimate goal is to increase the cultural and linguistic diversity of participants in this conference, and also facilitate the exchange of diverse ideas, views, opinions, expertise, experiences on biodiversity conservation to make this conference truly inclusive and productive for anyone. So we are really excited and are looking forward to seeing so many people with different backgrounds next year. So you might wonder, you might have thought that doing all these things might be highly labor intensive. But it's actually not. It's not that huge task. So all these things are done by these amazing members of our language accessibility subcommittee. And we just meet up once every month. And then we work on these things perhaps a few hours per week. So it's not a big commitment. But what's really important here is all these people are highly passionate and committed to addressing this issue of language barriers in science. So if you just have a small number of really committed people, any conference should be able to implement these initiatives to support non-native English speakers and also promote the participation of culturally and linguistically diverse people from around the world. Okay, so that basically concludes my talk today, but thanks very much for listening, and huge thanks to our project members and also over 130 collaborators from around the world. So it is their skills in a wide variety of languages, understanding of the diversity of cultures, and knowledge on local biodiversity and science, and above all, their passion for science that has brought our project a long, long way. So I truly admire and appreciate their contribution to our project. And we are still working on lots of really exciting research and solutions. So if you are interested, please visit our website, read our papers, and contact us anytime for any collaboration, joining us. Let's work together to solve this important challenge in science. Great, thanks so much.
Good morning. Thank you, everybody, for coming. I'm Natalia. This is Jen. We're going to be presenting a talk on the role of understudied populations in expanding the horizons of animal behavior, with a focus on our study systems on African lions, and Stacher, who couldn't be here, who focuses on African and Asian lions, will be presenting his slides for him. We also wanted to give a quick acknowledgement to our other two main contributors here, Meg Crowfoot from the Max Planck Institute of Animal Behavior and Joseph Bump from the University of Minnesota.
So the African and Asian lions have a very widespread distribution across sub-Saharan Africa and a little pocket left in India in the Gir forest. Despite this widespread distribution, when we look at, say, the top 100 cited papers on the topic of the African and Asian lion, what we see is these are disproportionately focused on the Serengeti National Park, Tanzania, which is a single population. This is largely the result of the fact that one of the longest running studies on lions was based here for nearly 50 years. And this was an amazing foundational data set that spans the kind of depth of time needed to understand some of these behaviors that occur over perhaps decades, to understand survival and recruitment consequences of different aspects of lion biology. It also happens to be, however, one of the easiest places to collect data on lions. It's a very open system. You have very small ranges. It's very easy to go and view the lions. And as a result, it's very tractable to find out information. This is a great thing, but what I think we would like to highlight in this talk is that we think there would be a lot of value in moving from lions do this to lions do this under these circumstances. And to do that, you need to have studies from other populations. This is something the three of us have been working on separately in our work and now are hoping to move together. And that's kind of the basis for this talk.
So we'll start with just kind of a brief primer on lion behavior, with the caveat that most of this comes from the Serengeti. So lions live in fission-fusion societies. The females form permanent units called prides, and inheritance into a pride is matrilineal. So if you're born into the pride as a female, you maintain residence in that pride. Prides defend territories, and then you have permanent social groups of males known as coalitions, and coalitions will temporarily gain residence with a pride to sire offspring and hopefully defend that pride from rival males to the point that the offspring are independent. If they're unlucky, then other rival males will come in and commit infanticide. Lion society is also fission-fusion, so within a pride you'll get subgroups of females. These subgroups form different functions, for example, hunting and communal cub rearing. One really interesting thing about lion societies that is in contrast to a lot of other social mammals is that they do not have a strict dominance hierarchy. Instead, they're egalitarian. So males and females enjoy equal access to food and equal access to mates. Lion societies are also characterized by a high degree of cooperation, mainly in the forms of cooperative hunting, communal cub rearing, and then communal resource defense. Now, in the Serengeti, the habitat type that lions reside in have these hot spots of resources. So there's river confluences where water is readily available, and there's very high prey densities. And this results in small, dense territory sizes where you can get a high carrying capacity of lions and very large pride sizes. However, as we mentioned, lions occur across an impressively diverse range of habitats, everything from mountains to beach to forest. And so what we're going to talk about here is how we think behaviors might differ under these different environmental conditions compared to what we know in the Serengeti.
And one of these habitats is the Gir forest in India. This is where lions live in a forested system, and they hunt predominantly on very small prey, and they have quite a unique spatial configuration with females overlapping with multiple male home ranges and males overlapping with multiple male home ranges. This has led to, I'm going to apologize in advance if I butcher any of this, because this is the core of Stoch's work, but I will do my best. In this system, this has led to some really interesting dynamics in terms of male coalitions. So instead of seeing egalitarian male coalitions, we see that when there comes to food sharing between males, one of the males will get the food over 50% of the time. We also see the same male dominating over 75% of mating opportunities. This is a really stark contrast to what is seen in the Serengeti, where this is a 50-50 split, pretty much. We also see differences in the sexual segregation. We see that females are mating with multiple males, and this is something that is, again, quite different from these really high-density, high-competition systems. Another aspect of this is who's spending time with who. So another part of Stoch's work and his focus is on male-female interactions. And what he's found is that the amount of time that males actually associate with females is really highly dependent on the size of the prey. So in the Serengeti and the crater, which are two different populations but very close together, you find these large prey and males and females associate a lot of the time. In the Gir, this is not what you see, and you see that females often depart from males. And this was kind of this went against a lot of what is unknown knowledge and was only made possible by a long-term study of long-term follows of unique individuals, genetic studies, and was the culmination of a lot of time spent gathering comparable data in this unique habitat.
And then another area that Jen and I spend a lot of time in are the semi-arid to arid systems of southern Africa, mainly Botswana and Namibia. And in these systems, you have low densities of prey, and so lions need to take any chance they can get at a meal, in contrast to the Serengeti, where you get these hot spots of high prey density. And interestingly, in these systems, what we're finding is that lions are significantly more likely to hunt as solitaries, and this is the case even when taking down really large prey items, such as adult giraffe.
I think something that's really interesting about these systems is just the scales of movement. So instead of moving over a home range of 50 kilometers squared, you're moving over 3,000 kilometers squared. So the nature of fission fusion and what it is to be together and apart just plays out totally different. And this is kind of the core of our focus in our joint postdoc. And we're also seeing, for example, in Kutsi Game Reserve, which is part of one of the largest protected areas in Africa, but has zero publications on the demography of the lion population there. It's the size of Switzerland for some context. We're finding male tenures of up to 5 years long with no contest from other males compared to an average of 2 to 3 years in the Serengeti. We've had one male death recorded from another male lion in 20 years. The rates of aggression, the rates of encounter, and the pressures on competition between lions seem to be totally different here. So this is something we've been working on over the last 3 years. What we're hoping to do now, though, is to join efforts with researchers like Stotra, who are also kind of studying lions in these other locations, to collect comparable data across all of these, using camera traps to collect data on the prey, using passive acoustic monitors to characterize other elements of the landscape. We're using single collars for males and females to track long-term changes in spatial configuration, and we're doing short snapshots of data collection where we actually collar entire prides to understand coordination, communication at a very fine scale. And this collaboration actually grew out of just meeting at a conference and realizing we had a shared interest in this. And this is something we feel can bring a lot of value.
So we've talked a bit about how bias in study systems can affect our understanding of species, but we also want to highlight the fact that a lot of this research, there has historically been bias in who is conducting it and who is publishing on it. So outside of South Africa, almost half the studies don't include authors from the study country. And this is something that Jen and I are very passionate about. We're actually giving a talk immediately after this. You're lucky to have us 2 times in a row, where we're going to talk a little bit about how we partner with local communities to be involved in research with local communities and include these voices from the countries where we work. Additionally, data shows that historically, women, Black, African researchers are not typically among the authors of field studies on African lions. And finally, although our study system is lions, we want to highlight that we do think this probably is occurring in other systems as well. And this is by no means a comprehensive list. It's just 3 that we could come up with off the top of our head. But for example, we can imagine situations where behavior differs between Yellowstone wolves, Gombe chimpanzees, or the spotted hyenas of East Africa compared to populations living in other areas. And with that, we will take questions. Thank you. So here we're going to talk a little bit about our research. This is kind of how Jen and I met originally, is working alongside trackers in the Kalahari region of Botswana, combining traditional research methods with modern methods.
So as I'm sure many of you are aware, tracking technology has seen a huge proliferation over the last decade. We're now able to collect information on animal location, activity, acoustics, and near kind of real time and at increasing resolution. And this has been so cool. But there are still limitations, particularly when you're looking at behaviors like group level or, say, territorial signaling that don't leave a very clear movement signature.
So one way to address the knowledge gaps that remain with modern technology is by using traditional knowledge. It's a really powerful tool, and it has the added benefits of you're engaging local communities in research, you're building capacity in these communities, and you're also strengthening and valuing these traditional skills that are being lost.
Studying large carnivores and semi-arid systems is inherently kind of challenging. Just partly because you have very low prey availability, and these are really widely distributed across the landscape and in an ephemeral way. You also have very low predator density, so you might have, say, 20 lions over 4,000 to 6,000 kilometers squared, and they have very large ranges. One of the areas that we've been working on this for a long time, or at least the last 10 years, is in Kutsi Game Reserve in Botswana. It's a semi-arid savanna, so it looks something like this. There's pretty much 2 habitat types. You have these open pan systems, and then you have very close, dense shrub. We've been working there with the NGO Leopard Ecology and Conservation.
And none of this work would be possible without the team at Leopard Ecology and Conservation, pictured here. When Jen and I first met 10-ish years ago, we were really interested in cooperative hunting behavior as kind of the first aspect of lion behavior to begin asking these kinds of questions. But studying hunting behavior in lions is unbelievably challenging. Hunts often occur in low visibility, so dense bush at nighttime. They're really infrequent and unpredictable. They can go days without hunting, and it's really difficult to observe all of the participants in a hunt. So if you're asking questions about cooperation and coordination, it's important to be able to see what each lion is doing. If you do manage to get a good data set, it's really time consuming. It's very challenging. And although modern technologies such as GPS collars can overcome some of these challenges, this is very costly and still has limitations. So Jen and I started, well, when I met Jen, she was telling me about the incredible skills of the tracking team that they partner with at Leopard Ecology and Conservation, and I cannot do them justice. Some of the trackers have grown up in the park. They have an intimate knowledge of the habitat and the animals there. So what we do to study hunting behavior is we work with a team of trackers. They are able to go out, they identify a GPS cluster of a lion, they somehow find the carcass in the bush. I would not be able to do that. And then they backtrack from the carcass, the prints of the lions and the prints of the prey. And what's really amazing about this method is that not only do you get the paths that the lions take, but you also get the paths that the prey species take. And this gives us a really unprecedented view into what is happening during these hunts. Additionally, you get more information than just the paths. You also get information on their behavior. So the tracking team is able to say, for example, what portion of the path the lion was stalking versus when it was running, when the prey started running. So we get what we call these backtracking maps. On this one, the orange and yellow are the lions, and the turquoise is an adult giraffe that these two lions take down. And in this way, we're really able to get at some of the questions about cooperation and how lions in these environments succeed that we wouldn't otherwise be able to get at.
So this is something we recently published on from other kind of different behaviors that we've been looking at, using tracking as the core technique, and also for population monitoring in the region. This is something actually that we highlighted in the previous talk, was that, so the citation and the quote we gave is actually from a study on bias in population assessments within Africa of large carnivores. And there's almost no inclusion of local people, either as co-authors or in the data collection. Using tracking as a form of surveying is a cost-effective method to cover really large areas and to employ local people, so they're involved in the assessment, and if you do it well, also involved in the results and the write-up. So this is something we've spent quite a lot of time doing with the trackers, and it's been cool because they've got to experience lots of different areas of Botswana, which there wouldn't necessarily be the opportunity to travel to from where they are in the local village, where there's not many people own a car. So that's been really cool. And I think I just wanted to maybe share some experiences of the time that I've spent working not as an academic, but as a kind of a research assistant with the NGO, with the trackers, where their intimate knowledge of the behavior of these animals has had quite profound impacts on how we manage the park and the area together with the Department of Wildlife. So our remit was to do fence patrols and monitoring over a 2-year period. And park management were really concerned about hyenas and porcupines digging under the fence. They said if you solve that, there'll be no more livestock predated. The lions will stay inside. And the tracking team said, fine, we'll do it. But we really believe that lions are a problem, they're digging. So I went out with them and we filled every hole along a 300-kilometer stretch of sand fence. We marked the places that had been used by lions. We put out some cameras, and lo and behold, the lions actually are perfectly fine digging their own way out of the fence. And, I think it was a wake-up call that, if you're not from the region, you can't just come in and say, maintain your fence. You have to have an understanding of how that plays out. Another area was we were looking at studying the kind of small to medium carnivores in the area. And this is outside of the IUCN range for servals, but the trackers said, yeah, but we've seen the tracks there. We've seen the tracks for years. We know it's there. We tried to put this forward, and it wasn't considered sufficient evidence that there were just tracks seen. So we put out some camera traps, we caught the servals, and we kind of have promoted that this is actually maybe a transient area that they move through at the minimum. And I think something I'd like to highlight is me and the members of the team have attended tracking conferences that are global. And in the United States, for example, that would be considered sufficient evidence immediately. So I think we have to think about why we don't value this knowledge in Africa the same way we would in the States. And one of the things we've been really working on at the NGO in our own research is explicitly building funding into our applications to support professional qualifications for trackers. So there's something called a cyber tracker workshop and evaluation. that will allow people to score differently in elements like track and sign, in trailing, which is actually following the pass for a long amount of time. And this is something we've found has facilitated professional development. It's even allowed us to motivate for a salary structure where moving up a rank in your Cybertrack evaluation is considered the same as achieving, say, a master's or a PhD within the research team, which is often hard to justify to donors for salaries. We have new generations being trained now. We've also had the first female qualified tracker. We've had exchange between other tracking communities within Botswana, which has helped with community building for tracking communities. And our trackers have said that being able to return to following the carnivores on the ground and interacting with them in that way has helped them to understand, especially for the younger trackers, their behavior, and has actually reduced their fear.
And finally, I just want to, again, highlight the level of knowledge that working with the tracking team confers. It's knowledge that I, having not grown up in the park, would never be able to achieve. We'll be out doing something and they'll make a suggestion about methods and I'll think, oh wow, that's a really good suggestion that I would not have come up with. Or I'll ask them a question about behavior and they just have an intimate knowledge. Like, oh, well, have you thought of this reason for a lion behaving this way? It's like, no, I haven't, but that is actually a really good point. So I think it's just really important to keep in mind that there is this knowledge base that has not been utilized. I think it's being underutilized, and I think it's also really important to place value on these skills and involve local people in the wildlife. And finally, we just want to thank the various institutes that have allowed us to carry on in this path. As Jen mentioned, we're on a joint postdoc with the Max Planck, so we're really big proponents of collaborative science and work very closely together, and it's allowed us to achieve things that we wouldn't be able to achieve on our own.
So I'm Drew, this is Matthias, and today we're going to be talking to you about many primates, what many primates is, what kind of projects we work on, and also how the work of many primates can be used to understand and address bias in primate research. Okay, so what is many primates? Many primates is what we call a BTS project, Big Team Science. We were founded in 2018. BTS, that's when a bunch of researchers get together to address research questions that we couldn't reasonably answer on our own. And Big Team Science projects are founded on openness and collaboration, transparency, democracy, ethics, and other open science principles. Like, for instance, we will always incorporate reproducible workflows with fair and open data. Our focus is on evolutionary primate cognition questions. And then secondarily, we also attempt to address replicability and reproducibility in the field, sample size and bias issues, lack of generalizability, and inconsistent methods. So what have we done? Well, generally, we conduct different kinds of phylogenetic analysis. So in that vein, we produce several reviews and chapters. And what I'm going to talk about right now is one we published in Japanese, Psychological Review. And so this is kind of all about the state of the field. So this is the primate phylogenetic tree. This is all of the species. And we conducted a review of primate cognition papers published in 22 different journals, ranging from very specific journals like Animal Cognition and IJP, to more distant or general journals like Developmental Science and Scientific Reports. And so we narrowed this down to 574 studies on 69 different species. That's these 69 species. And so if we zoom in on some of the hot areas here, so these are the apes mostly, and you'll see the size of the circle represents the number of studies. Mostly that's with pan-troglodytes, chimpanzees, but you also see gorillas, bonobos, and orangutans. And then up top, you've got a few lemurs. Then if we move over to old world monkeys, the biggest dot here is for macaques, particularly rhesus macaques, but you see some representation from the marmosets up above. If we look at the New World primates, it's mostly capuchins, that's the biggest group, but there's also some squirrel monkeys, and at the very top, mouse lemurs. So but it's quite limited. You can see just how limited the species representation is. And there's also bias in where this research takes place. So we surveyed 183 different data collection sites, and the biggest of those are in Germany, the United States, and Japan. And mostly the concentration of research is taking place in the Northern Hemisphere, in places like Europe and the United States, what we might also call the global north. So to summarize kind of all of what we found with this review, only 13 out of 16 primate families were studied. There's no research on babies, bush babies, galagos, various lemurs, and very little on owl monkeys, gibbons, and attalids. 38% of all studies were on great apes, and out of those, a very large proportion were on chimpanzees. 40% were on older monkeys, and among those, almost all of them were rhesus macaques as well. Then if we looked at sample size, I mean, there was quite a range here. We had sample size as small as 1, but as large as 481. But the median for all studies was only 7. And 66% of all species had a median study sample size 10 or less. And those giant studies, those large median samples, they're only found in overrepresented species like rhesus macaques and chimpanzees. In terms of sites concentration, like 5 sites concentrated 38% of all studies, and again, those are all in the global north. And most studies did not do any kind of species comparison. So this provides quite a few problems. Like if we want to have an inference about primate evolution, no single species can really represent what we want to understand. We need to look at the entire evolutionary trajectory. And so we need a fuller tree to look and answer these evolutionary questions. And even if we have imbalance in the tree, for instance, we have a strong bias towards having more macaques than other old world primates, macaques tend to be more socially despotic, so there's a chance we're not going to be able to answer the kind of social questions we might be interested in unless, again, we have a very balanced tree as well as a full tree. And all the materials for this paper, you can read the paper in JPR, and all the materials we used to make it, and those plots are available on our GitHub. So we've done several reviews like this, but the core of our work is empirical. So we've had 3 empirical studies. MP1, Many Primates 1, that's out there. You can read. Many Primates 2 is wrapping up right now, and Many Primates 3 is ongoing. And we also have some future work that we're developing, looking forward at wild captive comparisons, personality, welfare, and other cross-project data linkage. But now Matthias is going to speak to you about what's going on with Many.
Fantastic. So we're ready for our next speaker, talking about the illusion of science and animal cognition.
Thank you. So I'd first like to thank Ben Ferrer, who's been working on this with me since 2018, first during his PhD, but also later on. So as we heard about in a lot of talks both yesterday and today, you now already know that there's an increasing number of us who are working on kind of issues of research integrity and research bias in animal cognition and kind of fields adjacent to animal behavior. So you also know that open science is somehow important to us. Many of us are part of the open science community, and this is not just because open science principles and open science tools are very important and useful for data synthesis, so evidence synthesis and kind of cumulative science, what we also heard in Antitsa's talk yesterday, but it's also that the open science community affords us a space that kind of gives us time and space to connect to each other and work on these issues. And it also unites us, because what happens is that different researchers working on research integrity are usually spread around in different labs, different institutions, also different disciplines, and different countries around the world. So the open science community is really important for us. Now, of course, we already know Twitter is dead. Twitter was very useful for us as well, so now we're kind of all moving to Blue Sky, so please join us there if you're kind of interested in joining the open science community. Now, what we also heard in a lot of the talks is that there's a lot of already initiatives and suggestions and approaches, and those sometimes target replicability kind of directly. And what I'm going to do in this talk is that I'm going to provide kind of a complementary story to that, and really it's a little bit of a cautionary tale. And what you will see is that I will argue that as we kind of look towards these different suggestions and initiatives and kind of approaches from primarily coming from psychology, what we need to take into account is the specifics of our research fields and anything that might make us potentially even unique. I will see that I will also kind of be wary of those approaches that are trying to push kind of a unified method for everyone. And we heard some of that already yesterday, and I thought this was a very good point that lots of speakers were making. So we already heard also yesterday in Freddie's talk that a lot of the kind of initiatives and approaches come from mainstream psychology. And they have been developed over a period of kind of 10 years as a response to the so-called replication crisis. So when the replication crisis hit, low rates of replications became widely known in psychology. And a lot of researchers, primarily very young ones, got deeply affected by that. And it felt that the foundations that psychology is kind of built upon are kind of shaky and are starting to collapse. But really, potentially, this should have never really surprised psychologists in the first place. Because if we read widely and kind of deeply into what psychological science is, there's always been really long-standing criticism regarding these shaky foundations. Now, this criticism partly came from within psychological science, primarily from psychometricians, as evidenced by the quote by Danny Borsboom here, but it also came from outside of psychology, primarily from historians and philosophers of science. And for both of these groups, the main culprit for these shaky foundations was always the lack of substantive theory in psychology. So when the replication crisis hit, we could have expected psychologists to now take this really seriously, right? And start working on theory development. But that's not what happened, at least not immediately. Instead, researchers in psychology turned over to open science, statistical inferences, and research practices, all the kind of things that we also heard yesterday and today. It is not until much, much later that there's a group of people who have started emphasizing the importance of substantive theory in psychology, again, as part of the open science community. And this primarily now came from computational modelers, who are, of course, also emphasizing the benefits of formalized theory. So armed with this knowledge about what happened in psychology, we can now turn towards animal cognition. And here I would argue that we can make the kind of argument by analogy, and that if we focus primarily on kind of initiatives that directly work on, kind of like approaches that target replicability kind of directly, then we might also mask, like in psychology, the underlying problem that we kind of share with psychology, and that's the lack of theory. Now, in our own field, that may be exacerbating by a lack of separation between test development and test use. So what do I mean by this? So in animal cognition, we design specific tasks, sometimes specific to the species that we're studying. And we design these tasks. And what we do is that we don't first do psychometric things. We don't first go and test the reliability of the behaviors that are elicited by that task. And we also don't spend time a priori discussing the validity of that task. We don't end up discussing whether this task is a good measure for the cognitive ability that we are interested in. Now, what often happens, there are some exceptions to that, and we saw some examples of this even at this winter meeting, but often what happens is that we design this task, and occasionally we get overly excited, and we just go and implement it. We go and test it with the species that we're working with. And so what we end up is the situation where we end up as a community discussing the validity of a measurement. So we end up discussing whether a behavioral task is a good measure of the cognitive ability that we're interested in after we already know the results in various different species. Of course, there's some scope for bias here because our evaluation of the validity of a task may then be influenced by to what extent the results that were already obtained align with our a priori notions of whether this species should have the cognitive ability or not. But when we talk about theory, then it's also a good kind of reminder that when we talk about the benefits of formalized theory, there is a lot of tradition about formalized theory in animal cognition as well, primarily coming from learning theory. And this is something that's also been emphasized by computational models all along, but now more so. And we see here some of the examples of quite productive collaborations of computational modelers and empiricists in the last couple of years in our field. But when we look at that, then we see that formalizing what is often known as kind of simpler or lower cognitive mechanisms seems to be easier than the formalization of kind of alternative mechanisms, those that might be underlying cognitive abilities that we often consider cognitively complex, whatever that may be. So I think here we see a lot of scope for both more computational work, but also more conceptual work in terms of us discussing what is cognition, what is the structure of cognition, how do cognitive mechanisms work. Of course, all fundamental questions in our research field. When we think that these kind of approaches that target replicability directly maybe bypass the important question of theory in psychology and then may do the same in our field, another thing we should be wary about is that very often these approaches coming from psychologists are targeted in kind of like a unified approach, so kind of a one-size-fits-all. And of course, we are a field that actually has a lot of pluralism. We have different research questions, we have different research methods, different animals that we work with. Some of us work in the field, some of us work in the lab. And we might be aware when we kind of look towards the different approaches and suggestions that we might find very useful of how to adapt them to our needs and our challenges. So one of the examples, and we talked about pre-registrations already yesterday, so I'm not going to spend much time talking about that, but pre-registration is something that we have to be aware of, that some psychologists and also somehow reformers from the open science community are thinking that we should be mandating. And so I find pre-registrations very useful for my own work, especially when it's coupled with journals in the form of registered reports. But at the same time, I'd be very cautious of trying to mandate or think about mandating pre-registrations in a field as diverse as ours. We also don't want to create some kind of situation in which we think that studies that are non-pre-registered are somehow less credible. And I think the sentiment was also echoed in some of the talks yesterday. Another thing that goes hand in hand with the pluralism in our research fields is also its interdisciplinarity can be a fruitful resource for us already today and yesterday. And I'd like to highlight that this is also a fruitful resource for us when we think about problems of reproducibility or wider research integrity issues. And here I just want to highlight that philosophers working in a field have already been really productive here. So if you don't know these two papers, please go and have a look at them. So here philosophers in our field have already been very useful in kind of providing a different perspective on kind of how replicability, generalizability, and theory all fit together. And another thing that philosophers in our field have been pointing out is that they perceive our work as kind of functioning under theoretical openness. And it seems, at least to me, but I might be wrong, is that the philosophers seem to be quite kind of more happy and more faster in accepting this theoretical openness in our field than many of us empiricists. And if we find these ideas of theoretical openness interesting or even convincing, then it is probably something that we want to think about. But hand in hand, I think, goes kind of working on greater uncertainty tolerance for us in terms of what the results of our empirical studies mean. And of course, this may also lead to adjusting our claims that we make in our published literature. Because if we say that we are working under theoretical openness, then surely this should be also visible in the published literature of animal cognition. So just to end, as we kind of go forward, and we're definitely probably trying to work on greater transparency and better evidence synthesis, so all things that you've already heard about, I'd like to add another thing to that. And that is that I would like to urge us to keep alive the discussions and awareness of some of these deep theoretical conceptual issues, and to not kind of forget that we have those as well. And also not to think that the kind of approaches that we've already advocating for might be able to resolve them. Because if we fall into that, then we're kind of falling into an illusion that we already have solutions for problems that we're not even voicing enough. Thank you.
Hi everybody, and hello to everyone online and in the hublets. The fun facts we had about speakers yesterday has kind of fizzled out. So in the spirit of breaking down barriers and connecting, I'll say that I love climbing, rock climbing, and playing board games, which makes me sound like a bit of a big kid, but perhaps there's a bit of that in all of us. So I'm going to chat to you about fieldwork, the who, what, where, and how of fieldwork. And I'm also going to ask you in a few slides what you think the most studied species has been in animal behaviour fieldwork in the Animal Behaviour Journal over the last 10 years. I'm going to come to the online people, so please put your kind of thought in Slido in a few slides. So when we do field work, we always aim to be inclusive and equitable in how we approach it and in our practices. But recently, in the past few years in conservation science, there's been published several high-profile papers highlighting the influence of historic legacy had in conservation science, conservation biology and ecology. So, for example, if my bullet points will appear, some examples: lack of engagement or capacity sharing rather than capacity building, which is, I think, a preferred term among some, with host country researchers, parachute or helicopter science, not only in the design of studies, of projects and dissemination of results, but before that actually happens, in co-conception of ideas and in identifying research priorities. Lack of recognition of contribution, as was mentioned earlier, authorship, including authorship, the valuable, essential work that trackers do, for example. And so my colleague Susie and I were interested in the relevance of this recent kind of highlight of studies to animal behaviour fieldwork, both being involved in field research. It can call for some uncomfortable conversations, and we absolutely, it's not about judging people, pointing the finger or apportioning blame. It's very much about focusing on what we can do better. There's, lots of good practice out there. How widespread is it, and how can we share good practice, and how can we improve things? So we asked the question, to what extent are host country researchers involved in studies taking place in their country? Our approach, we looked in the Animal Behaviour Journal just in the last 10 years. We used the search string fieldwork on wild. Without that term wild, we got over 3,000 articles, but this pulled out 162. And we asked the question, what's the relationship between author affiliations and where the fieldwork was carried out and collaboration. We looked at lead authors, both as first authors only and then first and last authors, and where studies are conducted. So this map shows you where fieldwork was conducted over the last 10 years in this kind of subset of papers. You can see by far the majority of studies were conducted in African countries, 57, followed by European countries, 37, 31 in North America, 16 Oceania, 11 in South America, and 8 in Asia. My next slide is the slide about species studied. Anything from online, Chiara? No? Okay. So if you saw the fantastic poster outside about animal behaviour affiliations and species studies, you'll probably guess. The most common studied species was the common chimpanzee, 16 of the papers, closely followed 14 articles by the great tit. You can see quite a few primate species in there, bird species, but we had 109 different species within that data set. And yeah, I haven't got time to show you a kind of little taxonomic graph. But moving on to where lead authors were affiliated, so this is just looking at the first author affiliation. You can see the majority authors, perhaps doesn't come as a surprise, first authors in European countries, 82. Followed by North America, 11 Oceania, Asia, South America, and 3 from countries within Africa. Putting the fieldwork location and lead author affiliation maps side by side, you can see the kind of disparity in where fieldwork is conducted and first author researchers from the host country. And in over 35% of the studies in that subset, there weren't any authors, regardless of whether they were first, last, or somewhere in the middle, were from countries where the study was conducted. This next graph shows you as a percentage of papers of first and last authors affiliated to institutions in host countries. And you can see that was greatest in Oceania. I know our sample sizes are quite small. And then Europe and Asia, around just over 60% for South American countries, similar in North America, and only about 12% from countries in Africa. So we then looked at percentage of papers where any authors were affiliated with host country institutions. We get 100% for countries within Asia and Europe, slightly less for North America, Oceania, around 70% for countries in South America, and it doesn't really change for countries within Africa. It goes up from 12 to about 14%. So we looked more closely at perhaps what's happening in African countries over the 10-year period, and you can see for several years there were no authors or researchers affiliated to host country institutions. There's a little blip there in 2017. There was a peak in fieldwork papers in 2017, not sure why. But the situation seems to be changing from 2021 over the last 3 years, which is really encouraging. The situation is changing. So how can we overcome barriers to collaboration? And be more inclusive and equitable? We don't need to start reinventing the wheel. There are many papers out there that have been co-created and co-consulting with host country researchers on equitable fieldwork practices. For example, providing and creating opportunities for co-conception of ideas and identifying research priorities, as we've heard all about today in Tetsu's fantastic talk this morning, identifying language barriers and thinking about ways to overcome those. Making sure that our collaborations are truly synergistic, that they're mutually beneficial to all parties. making sure that we invest in capacity sharing with individuals in host countries, and looking at who we credit with authorship and who we recognise in that way in publications for authorship. And it was highlighted earlier about perhaps that we perhaps don't have had a history of not giving credit to individuals who are involved and perhaps that haven't been considered to contribute intellectually. But we have our contribution role taxonomy, which Elsevier and the Animal Behaviour Journal and many journals ascribe to, and one of the 14 roles is for investigation and in data collection and running experiments, the investigation process. And why don't we use that more? So next steps. For us, we've only analysed 10 years. We couldn't find a good way to extract the data automatically because actually affiliation within animal behaviour is in quite a few different formats, so we just did it manually, but we want to go further back. We want to have a look to see, is there greater recognition in the acknowledgement section, perhaps? Perhaps that's where it's being hidden rather than in authorship. We've started some analysis to look at gender. First authors were more likely to be females in our subset and last authors male, but we want to look more deeply into that. And we also want to look to see over time, is the situation different in Asia and South America because it's improved recently over time there, or has it been static over a further period going back? So I want to really throw the question out to you, to field researchers out there, how can we identify and work to overcome barriers to collaboration? And we've already heard some fantastic ideas, and I'm going to go away with ideas. I don't have the answers, but we can work together to discuss that and find out. Thanks very much.
Greetings everyone, my name is Jayshree Mazumdar and I am from Indian Institute of Science, Bangalore. And today I'll be presenting this particular paper which is on gender affiliation and research biases in primatological studies in India. When I talk about primatology, names like Jane Goodall, Diana Fossey and Groot Galdicus, often referred as primates, comes to our mind, as they have transformed the field, showcasing the power of meticulous observations and long-term commitment a woman can give to this field. These trailblazing women have not only advanced primatology but also have broken many stereotypes in the historically male-dominated discipline. However, when I talk about India, which is home to 26 native primate species, including iconic species like the lion-tailed macaque, rhesus macaque, and Arunachal macaque, there still seems to be some discrepancies or gaps. Indian primatology began gaining prominence in the mid of 20th century, with researchers such as Meva Singh contributing extensively to behavioral ecology, conservation, and evolutionary studies. Additionally, there are other researchers also who have come into focus, but that is also strictly the males. My focus is to understand this gender and institutional and research biases in Indian primatology. Through an analysis of publication trend and systematic challenges, we will try to explore ways to make an Indian primate research more equitable and impactful. Coming to the methodology section, I have divided this particular section into 3 phases. First is a data collection phase in which I have collected all the studies which is done in the wild habitat, and I have collected 315 articles. These 315 articles were further divided on the basis of the publication characteristics, the authorship, the collaboration pattern, and the research focus. The focus was to identify the patterns of gender representation in first authorship, senior authorship, and overall publication output, allowing for an understanding of gender disparities over time. Additionally, I aim to uncover how collaborative patterns influence the visibility and impact of researchers, as well as whether certain authors or institutions are more likely to engage in international research partnerships. The last is the analysis phase. So, the publications were examined across different time periods to analyze how the representation of women, research priorities, and collaboration pattern have evolved. This temporal analysis provided insight into the growing trends in Indian primate research and the changing dynamics in authorship and institutional participation. Through this approach, the study provides a comprehensive view of the structured dynamics influencing Indian primatological research, offering insights into areas that requires greater equity and diversity. Now, coming to this particular slide from which I talk about the results of my study, the first result is talking about the publication trend. Now, from this particular analysis, what we see is that the number of publications has risen sharply since the early 2000s. However, this growth has not translated into equitable representation, as in biases still persist across gender and institutional domains, which I'll be discussing further in the next slides. Now let us focus on the impact factor of journals and whether there has been a significant trend in its changes over time in Indian climate research. First, when I talk about the impact factor, the analysis revealed that the impact factor of journals publishing Indian climate research has shown a gradual increase over the past 2 decades, particularly since the early 2000s. This trend reflects the growing recognition of climate research in India and its increasing global relevance. The shift has facilitated a more prominent position of Indian climate research on the international stage. Now, there could be some potential influence on this impact factor. The increase of impact factor can be attributed to the enhanced research quality and improved funding for climate conservation and ecology in India. Second, the growing international collaboration, which allows researchers to target higher tier journals. And last but not the least, advancing digital platform and global research database, which have made Indian research more visible worldwide. Now that we know about the publication trend and the impact factor of the journals, let us talk about the gender disparities. Now, the data reveals that only 17% of the total authors are females and only 30% of the first authors are females, which means that males are taking a leadership in authorship as well as being the lead authors. So the male authors dominate the prestigious journals and international collaboration. This underrepresentation reflects the systemic biases such as limited mentorship, network, and research or leadership opportunities for women in the field. Furthermore, on this slide, I'll focus on the trend of the female leadership or the authorship, which I was talking in the previous slide, in Indian climatological research. The analysis revealed that a significant increase in the proportion of publication led by females over the years, highlighting a positive shift towards gender equity in this field. However, when I talk about the historical trends, initially female representation in lead authorship was low, with men predominantly occupying the first author's position. However, from the early 2000s, there has been a steady rise in the number of publications where females take the lead, with a notable surge in the last decades. This shift reflects a broader trend in academic publication with greater gender equity that has gained more attention. In this particular slide, I have tried to analyze how the gender of the lead author and the proportion of female co-authors are related, and it reveals a striking and significant pattern in the data, highlighting how the gender of the lead author influences the gender composition of the co-authors in the team. When male researchers are the lead authors, the proportion of female co-authors is noticeably low. However, when female researchers take the lead, the gender balance among co-authors improves with a higher proportion of female co-authors. This indicates that women in leadership roles are more likely to collaborate with other women, creating a more gender diverse research team. This pattern suggests that gender biases in academic collaboration continues to persist, especially within male-dominated research teams. Men, even in collaborative settings, may be more likely to include male colleagues, while women, when leading research, may promote greater inclusivity and diversity in their team. The findings underscore the need for institutional support to create a more inclusive collaborative environment, especially in the field where female researchers are underrepresented. On this slide, I have tried to explore the affiliative biases that can shape the composition of research team, influence the collaborative network, and impact the visibility and success of certain researchers. Affiliative biases influences more than just the team compositions. It can have a profound consequence on the distribution of resources, access to high impact factor journals, and opportunities for career development. For instances, male-dominated collaboration network may result in concentration of power in the hands of a few, limiting opportunities for broader presentations. Conversely, increasing female representation in senior positions could help counter these biases by facilitating more equitable collaboration and expanding the range of perspectives included in research. In conclusion, affiliative biases remains a significant factor in shaping the collaboration network in climate research. On this slide, I examine the publication house and regional biases in Indian climatological research. Now, the data clearly reveals that a significant portion of Indian climate research that is published in international journals with higher impact factor are from the Western countries, which may lead to biases in terms of what gets published and who gets to publish it. A disproportionate amount of research is published in global journals where Indian-based journals are underrepresented in the high impact factor research publications. This trend could be indicative of the broad dominance of Western-based academic publishing houses, which tend to favor authors from high-ranking institutes mostly located in North America and Europe. Researchers from smaller or less well-known institutes face barriers in accessing these high-impact factor journals due to factors such as international networks, lack of financial resource for publication fees, and the competitive nature of these journals. This disproportionately affects the researchers from regional institutes and women who have often fewer resources and institutional support. When I speak about the species that are being considered for study, we see that the research efforts is concentrated to a few flagship species such as the lion-tailed macaque and the mixed species studies, while endangered species like the Arunachal macaque and some other species of langur receive limited attentions. These biases reflect the influence of funding availability, accessibility of the study species, and of course the institutional priorities. Coming to the key findings of my study. First is the underrepresentation of women, who accounts for only 17.5% of authors and 30% of the first authors, showing a persistent gender gap. Despite an increase in the female leadership role, systematic barriers such as limited mentorship and gendered network practices hinder the women's access to higher roles and also publication in higher impact factor journals. Male authors are more likely to collaborate with other males, forming an exclusive academic network that restricts women's participation. Top-tier institutes produce over 60% of the publications, with researchers from regional institutes facing barriers in accessing high-impact factor journal articles. Male-led research team is more likely to publish in prestigious international journals, while female-led research team often appear in regional or low-impact factor journal, contributing to an inequitable global destination of research. Finally, dominant species like the lion-tailed macaque receive the most attention, while endangered and lesser-known species such as the langurs and other macaques are underrepresented or under-researched. Thus, we see that these biases have profound implications. First, we see that the gender disparity reduces diversity in scientific representation. Second is the institutional dominance centralizes knowledge production and marginalizes the regional voices. Third, the thematic and species biases constrain the breadth of research, limiting its impact on conservation and policy. Therefore, I have put forward 4 points which requires major attention, but my main take out on an individual level to everyone is that haters are always going to hate and cheaters are always going to cheat, but you can't let them stop you. And together we can ensure that our field becomes more inclusive, impactful, and representative. Thank you everyone for your attention, and now I'm happy to take questions or hear your insights on fostering equity in climate research.
Okay, hello. I am Kate Potter, and I'm going to tell you about a course I designed and taught. And so first, I'll tell you that I am a PhD candidate I will be finishing in several months. I am a neuroscientist and a social justice educator, and I'm educated both in, I'm getting a PhD in neuroscience, but I'm also getting a graduate degree in social justice education. I research predatory behavior using sea slugs, which I have a picture of here, and my teaching generally exists at the interface of social justice and biology, and very often biology for non-biology majors. And so I come to this course, like the course I've designed here, with kind of the basis that inclusive biology education is absolutely essential. I think something we forget often is that the students we're teaching become researchers, and of course the knowledge that we produce in our research becomes content for teaching. And thus, if we want to have an accurate understanding of the natural world, we need to both include marginalized and historically excluded scientists and observers, and we also need to consider many alternative hypotheses and interpretations of observations. And as we've heard about throughout this conference, those are intertwined. People who come from diverse backgrounds sometimes have an easier time coming up with alternative hypotheses and presenting them. And so, teaching and researching the complexity of biological sex and sexual behaviors is really essential for accurate scientific research and for equity, inclusion, and justice. And so I'm going to tell you a little bit about the structure of this course before I get into some of my results. And so the course that I taught was a first-year seminar. And so at the University of Massachusetts Amherst in the United States, every student incoming takes what's called a first-year seminar. It is essentially they're given a list of course titles and descriptions. It's 19 students max. They are taught and designed often by teaching fellows, which will be graduate students and postdocs. And the first-year seminars include core content that all first-year seminars cover, and then whatever the course instructor's additional content was. And so first-year seminars across the board, they're addressing the hidden curriculum of college, how to make connections, and self-care. But I specifically titled my course Biology But Make It Gay. Yes, a lot of students took the class purely because of the title. I have that data. And so I taught 4 sections of 19 students each. I taught this in fall of 2022 and fall of 2023. And so a bit about this course. There were some process goals that we had for the course, and so this was namely building a learning community of kindness and respect. And as far as content goals, the hope was that students would understand what it means to quote-unquote queer biology, give examples of diverse sexual behavior, identify underlying assumptions and models about that humans are using to understand sex, gender, and sexuality. And so the topics that we covered, so there were 3 main content units. One was kind of a queer theory perspective and thinking about what queer and feminist approaches to biological research look like. Then we talked about what is sex, so how do scientists determine sex, and how do animals do sex determination, which ends up being very confusing terminology for students, as I learned. You can't use determine when you're talking about a researcher figuring out what sex an animal they're studying is. Just a pro tip. And then also sexual behaviors. The main form of assessment that I used in the class was weekly reflection journals, and so these had 3 components. One was a community guideline check-in, which was used to maintain class community and address any injustice or harm as it occurred. I also did content reflections so that I could assess understanding and reactions to course content, and I would get feedback so I could adjust learning activities in the moment. As far as my pedagogical approach, I'm going to give a few examples of ways that I taught. So the first, this was an activity explicitly mentioned by 75 out of my 76 students as their favorite activity. And so it's a myth or fact game. It is a method of knowledge transfer because sometimes you really do just need to tell students things, but you still want it to be fun and engaging. And so students would be in groups. I would present to them a statement like female hyenas have a penis. They would discuss in their groups, is that a myth or is it supported by scientific evidence? And then I would present to them information. Then we go on like an answer. Then they get some scientific information. Let's learn about the biology of hyenas. And then if it was relevant, we move on to different societal connections between content. So how have hyenas been represented in media and thought about within society at large, historically and currently. Another example was kind of connecting evidence to scientific hypotheses, and so this was using a review paper that was published about same-sex sexual behavior in Lepidoptera. And so for this activity, students were given a list of different hypotheses and lists of evidence, and they had to sort of match which hypothesis they thought the evidence was in support of. And we also had an activity that went in reverse. So for this activity, students were in groups. I would present to them a hypothesis for same-sex sexual behavior, such as same-sex sexual behavior is occurring because of captivity. Then students would come up with what's an experiment that you could use to disprove or support this hypothesis. And then I'd present to them an actual, results. And for this activity, I used a vast body of literature on macaques. I'm going to skip this in the interest of time, but if you want to hear about the historical perspectives activity, I would love to talk about it. So this was a Scholarship of Teaching and Learning project. It was approved by the UMass Amherst Institutional Review Board, and so I have collected data from my students. The questions that I was working to address mainly is how does centering queer and feminist perspectives in the teaching of biology influence sense of belonging and understanding of like the culturally embedded nature of biology. So in fall 2022 and fall 2023, that's when my students took the course. In fall 2024, they got an email from me that was like, hello, hopefully you remember me. We spent a lot of time together. Would you be willing for me to use your assignments? And there was also an anonymous survey as part of that. The data collection has been ongoing. I will say I got IRB approval 2 weeks ago. So we were getting real stressed leading up to this conference. But I created an a priori code of different terms I was looking for and patterns of thought process, and have been identifying emergent themes as well. Okay, so as of this morning, I actually had 36 out of 76 students consent, but when I submitted the talk, it was 24, so here we are. In terms of student demographics, the majority of my students were either cis women or some form of gender nonconforming or trans. It was predominantly white. I am at a predominantly white institution, so it kind of matched, though I did have a lot of Asian students. Why students selected the course? The two main responses were that it sounds interesting, or I am queer and I want to take this. And there was some overlap between them, but they were largely separate, which was interesting to me. A little bit about course themes. So we ended the course by creating concept maps. So I asked students, what are the main themes from this course that you got out of it? And they would shout things out at me and I'd write them down and we kind of condensed a list. And so the main topics, and I have examples of what exactly they said that you can read for yourself, but one was that queering biology is challenging norms and assumptions in science. Another is that biology is filled with natural diversity and variation. There's a reciprocal interplay of science, culture, and language. That understanding biology requires a historical and contextual analysis. That we need critical and reflexive approaches to knowledge production. And that broadening scientific perspectives leads to better and more accurate science. Okay, gotta really hurry here. So there are three main themes I'm gonna pull out. One is that students felt a sense of community and safety in this class, and would say things like, I was in an instant community of queer people and allies, which helped me feel grounded in my identity, even in a large college. Another example is that students connected the content to their identities and worldviews. So things like, I never believed that non-human relationships were all heteronormative, so I'm excited to learn. Or as an asexual person, what I deemed a sexual behavior was different from what we talked about in the class, and that was interesting. And the one I'm most excited about was students started to begin to view biology as diverse, dynamic, and open to interpretation. So things like biology is something where anything can be a possibility and things like that. And I don't have time for that, sure. Acknowledging people, and something one of my students said in a reflection journal that I think encapsulated the spirit of the class. We aren't talking about gay animals, but how to make spaces more inclusive for everyone, not just those already comfortable there.
Hi everyone. So as mentioned, I'm Natasha Rossi. I'm one of the co-founders of Animal Behavior Live, and I'm speaking today in the name of the ABL Society. And I will present methods to design inclusive international conferences based on our experience with the ABL platform. So international conferences are particularly important in the researchers' careers because it allows us to get feedback on our research. It's also a networking opportunity to build potential collaborations and to seek job opportunities. And to date, the face-to-face conference is the traditional format when it comes to international conferences. But this format comes with several limitations, one of them being economic, with registration, accommodation, and transport costs being quite high, especially for young researchers or researchers with no or very few funding opportunities. And this study, recently published in Geoscience Communication, illustrates this problem quite well. So they found that the attendance at this particular conference, the European Geoscience Union's General Assembly, was primarily controlled by the income metric of the countries represented. So you can see on the plot on the right, the number of participants to this conference versus the gross national income per capita in USD dollars. And you can see that the highest number of participants came from the richest countries represented in this conference. They also took into account the distance to the conference and the population density of the countries. And the population density was not factored, didn't have much of an effect on the attendance, but this attendance was primarily controlled by the income metric and then the distance to the conference. Then, of course, there are environmental limitations due to the need to commute between countries in order to participate in person, which in most cases is done by air, thus contributing to global CO2 emissions. And here, in this study published in 2021 in Political Science and Politics, you can see a comparison of the carbon footprint of the virtual edition of this conference, which happened online due to the pandemic, versus the carbon footprint of the same event if it had taken place in person. And you can see that the carbon footprint of the virtual conference was 97 to 200 times smaller than the in-person conference. And this carbon footprint for the physical event was primarily driven by the travel carbon footprint. So as you can see on the map on the right, you have the airplane and land-bound routes to the conference in the previous edition of the same conference. And there was a non-negligible portion of attendance relying on air flights to attend the conference. And finally, the last limitation, which is partly a consequence of the two previous ones, is the lack of inclusivity in in-person events, which translates, for example, in limited access for researchers with family duty, and a limited representation of speakers' diversity in the community, which is illustrated well by this study published in Nature in 2019. So you can see that among underrepresented minority authors, a bigger proportion of abstracts were submitted by students and early career scientists compared to non-underrepresented minority authors for the same exact career stages. And in the case of underrepresented women in particular, which are represented in light blue on the plot on the right, you can see that they comprise the group that was the least likely to be invited or assigned to speak at the conference, but they were overrepresented in requesting to present posters. So since our creation, our main goal at ABL has been to address these limitations and bring together researchers in animal behavior from all around the world to discuss the latest research and challenge our academic practices. And to do so, we rely on 4 design principles, the first one being our communication strategies. So we are trying to reach the widest community possible. And to do so, we rely on targeted emails to universities and societies. We also have a monthly newsletter, a website, and we are present on various social media networks to reach different communities. It was also very important for us to make all our events completely free of charge and rely on free and open access platforms such as YouTube for our live stream events, but YouTube also allows participants to watch the replay of the videos at their own convenience, which is practical for people with caring duties, for instance. And we also relied on Discord as a platform for socializing to provide a sense of community, although we know that it is a challenge for virtual events. And we also made our live events accessible for the widest audience by allowing the highest number of time zones available during our conferences. We also implemented an intersectional, fair and balanced abstract selection process. So a committee within ABL was in charge of evaluating the abstracts. They were blind to any identity cues of the people applying for talks or posters, and then scored the abstracts based on the scientific interest, scope, and implementation of the research. And then they made sure that this selection was balanced in terms of continent representation and they made sure that the demographics of the selected abstracts matched the demographics of the widest community in animal behavior life. And to do so, we rely on surveys that we circulate before and after each event. These surveys collect data about the demographics of the animal behavioral community at the international scale, which helps us inform our decision. So these are the results for the first edition of our conference in 2020. These are the results for the abstract submission. So you can see that there was the largest proportion of students who applied for posters compared to talks. And the reverse was true for postdocs and permanent researchers who applied preferentially for talks over posters, which I guess is a common pattern that we encounter in conferences in general. In terms of continent distribution, you can see that there was an overrepresentation of European and North American scientists who applied for talks over poster for this edition. And the reverse was true for South American scientists who preferred to apply for posters over talks. And we think that this is due to a language barrier. So I would very much interested in knowing about the tools that you develop for your conference. And then in terms of gender ratio, we had a slight overrepresentation of male scientists who applied for talks over poster compared to female scientists who were slightly applying for posters more than talks. And this is the result once we apply our abstract selection process. So you can see that the proportion of people from varied career stages was a bit more balanced in terms of posters versus talks. We achieved a perfect representation of continents when it came to talks, thanks to the selection process, which also rebalanced a little bit the proportion in terms of posters. And we applied a 70% female versus 30% male ratio for the talks, which matched the demographics of our community. So I only have 2 minutes left, so maybe I'm going to brush over since 2020, what happened. But I'm going to talk briefly about the limitations. Obviously, the main one is internet access because it's an online event, so we completely rely on internet infrastructure, which is dependent on the country participants live in. Platform access is also a limitation. YouTube is not available in China, for instance, so that's also a limitation that we would like to work on. And obviously, the community engagement and networking opportunity on virtual events is quite limited. And finally, the international aspect of our events is represented in our society. So we are welcoming more and more volunteers coming from all around the world, which we hope will ensure diverse solutions to the challenges we are facing and help to increase our reach to more countries. I'd like to thank you for your attention and thank our sponsors, the Company of Biologists and the University of Sussex, who funded part of our activity this year. Thank you.
Hi. So in this talk, I'm hoping that I can highlight ways we can spot and address coloniality in animal behaviour. And I want to do that by understanding the history that it's had and how this still has impacts today. To do that, I'll be drawing from many different fields that have been influential in creating what we know as animal behaviour today. I'm hoping we can find ways to see, disentangle and address these legacies of coloniality in our work, and I'm going to do this through a series of questions as well as drawing from a bunch of different examples. And I'm going to try and specifically focus on knowledge generation and dissemination. So, what is colonization? So we're talking about a period a period of time starting in around the 1400s, though others would say it's a practice of subjugation and domination, and others still would say it's something that continues today. But I think this image really highlights just how globally prevalent it was with the number of countries that were colonies versus colonizing. And what is a colonial legacy? So these are systematic privileges and ideologies that are historically imposed by colonial powers and reinforced in the present day and continue to shape the world.
And they've laid the groundwork for many of the systematic inequalities and injustices we see today, and we've also heard about continually as well. And though in this talk I'm very much trying to focus in a UK context, as well as on race, this is very much applicable to other parts of the world, as well as other types of marginalizations, as well as how they intersect with each other. So to start with, I'm going to talk a little bit about knowledge creation, both in the past and the present. So we can think about the specimen we use and where they've come from. And some of the questions we can use to try and disentangle these colonial legacies are: where were these acquired, who acquired them, and how were they funded? This is especially useful if we're working in places like museums, with private collections, or in botanical gardens. Kew Gardens is an example of this, where they have engaged in economic botany, where they've forwarded botany to increase British colonies, British colonial interests and prosperity, as well as biopiracy, where they stole seeds from some countries for profit. And this has had devastating impacts in biodiversity as we understand it today, as well as Indigenous knowledge that's often gone unacknowledged and disregarded, which has been integral to our beginnings of our understanding of some botanical knowledge. We can think about institutions, so where we do research. An easy example of this is universities, both within how they've been funded as well as the research they've carried out. So things like have they engaged with race science or eugenics? And universities are doing this more and more, both interrogating the passive ways they've engaged with this, where, for example, by receiving private collections or endowments, as well as the active ways they've engaged with this as well. So, for example, investing in things like the transatlantic slave trade. We can be clear about who creates knowledge or who has been allowed to create knowledge in the past, and talk about why a lot of our legacy is white, wealthy, able-bodied European men, and why this has often led to a disregard or dismissal of Indigenous and or local knowledge. And this really comes down to a systematic exclusion of people founded on race science. And this is a belief that some races were more evolved than others, and therefore more intelligent and more adept at intellectual tasks like scientific discovery. And this was in part formalized by Carl Linnaeus in his Systems of Nature, the 10th edition, which this image kind of exemplifies. Though he definitely wasn't alone, and this has been perpetuated, studied, and popularized by many scientists at the time, all the way through to the 20th century, and if anyone's read The Guardian recently, even into the modern day. And what this has led to is the justified exclusion of people. And this has continued today, and again, we've had many great talks alluding to this, where there's a continued global northern dominance of previous colonial powers, as well as a continued underrepresentation of marginalized people, both within animal behaviour and the UK more generally as well, in STEM. We can think about our practices, so how we conduct research and who holds the power in these dynamics and why. And again, a good example of this is parachute science and helicopter research, which we've had some amazing talks on already. And this is where researchers from resource-rich countries go to resource-poor countries and don't engage with the local research community or community at all. And what this does is it perpetuates and continues historical imbalance in power dynamics and is quite exploitative. It can also lead to a limiting of our perspectives, and again, we've had many amazing talks about sexual selection, but just to contextualize a little bit in terms of colonization, we can ask ourselves why certain ideas were thought to be more worthy of investigation than others. And so for sexual selection, Victorian ideals of gender relations were very much important to the conceptualization of men being the active and females being the passive, and as well as a historical focus on mating. And though this dominant ideology left much of the behaviour we see unexplained, it was the dominant ideology and really only got challenged around the 1970s with an increase in queer women and feminist scientists, which were ready to challenge this Western heteronormativity and broaden it out. And again, as we saw this slide yesterday, it feels like longer than that, but yesterday, this is continuing today. I'm going to shift a little bit now to talk about knowledge dissemination. So questions we can ask ourselves about how to spot the colonial legacies in knowledge dissemination are who we are teaching about and how we are teaching, and this very much is applicable to things like decolonizing the curriculum. As well as when we share knowledge, we can think about why there is a dominance of the English language, the common names we use and why they are often not connected to the local places these species come from, as well as an inequality in access to many things, not only journal access, but also access to conferences because of visa requirements and the like. And specifically for scientific figures, we can ask ourselves how they did science, where they did science, and what views did they hold. And Charles Darwin is a good and easy example of this, I think, where his voyage on the HMS Beagle was in part to further British interest in colonisation. Some of his science was done in colonial territories, and any Indigenous knowledge that helped this was not acknowledged. And the views that he held, and though it was a progressive view at the time, that all races had a shared humanity, he still believed in a racial hierarchy with white European people at the top, though he believed that the other races could achieve this pinnacle through civilizing missions. And while I've tried to focus a little bit more on animal behaviour, science in general was a tool of empire. Scientists founded race science, and this was used as a justification for the subjugation of people. This was also, science was also used to justify a moralizing mission of why colonization was needed to civilize the rest of the world. And I think this quote perfectly exemplifies that, where slavery was not just an economic cornerstone of a colonial education system, but an intellectual one, and was developed in the ivory towers and living halls of the first American colleges. And though they're talking specifically about America, this is very much applicable to the UK as well. And I think Sir Francis Galton really exemplifies it. And he was a eugenicist and race scientist. And when these ideas fell out of popularity because of the horrors of the Holocaust, these people didn't disappear, they just moved into different fields. And so where he was before the personal chair of eugenics in UCL, he then became the chair for genetics instead. And so what do we do? So the next steps and understanding what to do can be quite daunting, especially when we're trying to dismantle and rebuild systems that have been in place for a really long time. But we can break it down into different actions. We can think about the first step as gaining knowledge and understanding these legacies. We can understand the long-term structural impacts they have and continue to have today. And then we can start changing our practices. We can disseminate knowledge and then work towards structural change of how we work, who we work with, and how this is funded, as well as other related, though slightly different EDI initiatives. And I think a great framework for this is decolonizing, which has been an ongoing conversation in the global south since colonization, but it's now becoming more popular within the global north and within research communities. And there are many, these are just a few, but there are many papers, books now that make it a lot more accessible. And lastly, though not leastly, thank you all so much for listening. I'm just going to take this off.
Hi everyone, I'm Marina. I'm a postdoc at the University of Tuscia in Italy. Very sad I can't be there with you, and would like to thank the organizers for giving us the opportunity to present online. So normally I work on animal collective behavior, but today I'm going to talk to you about a side project that I actually started during my master at Imperial College London. And it's about the scientific impact of gender in animal behavior. So what I'm going to talk to you falls into the largest category of science of science, so the discipline that looks into science itself as a combination of networks between scientists, output, ideas, and to try to understand the structure and dynamics of science across different fields. So a bit of a background when it comes to gender bias, apart from different ratios, gender ratios in starting pools across discipline, it has also been found that women tend to be less involved in some international collaborations, and at the same time, other studies have found that the more countries are involved into a given paper, this paper will have a higher citation performance. So the combination of the two might lead to women having less impact. The work of women might have less impact. At the same time, some earlier studies have shown that women tend to reject talks invitation more often. And this, of course, can also have an effect since this is where we promote and showcase our research. Finally, a more recent study 2 years ago found that women might be less credited in science than men, that they might have less good positions in the authorship group or not even included at all. So when I was interested in gender bias back in London, I got very influenced by these websites that were looking into showcasing the different gender ratios in different events or promoting women in science. And I got an Equal Opportunity Initiative Fund from ASAB, the European Society of Evolutionary Biology, to develop Bias Watch Evol, so looking into the gender bias in evolutionary biology. And what I was focusing on mainly was some types of gender inequalities that I thought might be in place. So first, looking into the gender bias in first author positions. Second, looking at the gender balance of different authors group. And third, try to relate those two into the citation performance of a paper. And I'm mostly following here previous methods by similar work looking into the scientific impact of nations. So in terms of data, I use this Elsevier developer program that you can download a bunch of papers from Scopus. So I downloaded information from 30 journals in animal behavior that led to around 25,000 papers. And from that, I can export information such as the name and the surname of all the authors, the publication date, the number of citations. And from that, there's actually a lot of packages out there where you can try to infer the gender of an author based on the first name. Of course, it's far from perfect. But the specific package that I use gives you this set of options. So for every first name, it gives you whether it's a male, female, how confident it is, so if it's mostly male, mostly female, or whether it's unknown or androgynous. And for the analysis that I'm going to present to you, I'm only using the papers for which the first author could be identified as a male or female, so that leaves us around to 19,000 papers in journals that might include work on animal behavior. So from that, I also calculate what we call this gender balance index, GBI. So assigning 1 to female names and 0 to male names, we can get the mean, the average of all authors. And from that, we can split our papers into belonging to a high male or high female author group, low male bias or low female bias, and a balanced. And then to calculate the citation performance, instead of using just the number of total citations, we are splitting. So for each journal, we are splitting the papers based on the publication year, and then we assign a paper to a different citation quantile based on where they fall within the distribution of their own journals on a given year. So this is again following the previous paper that I mentioned. So every paper is assigned into these categories from 1 to 5. And some quick first results, numbers. So the all authors gender ratio, so men over women, is around 2.6. So for every woman author, we have 2.6 men. And in the first authors, this gender ratio falls a bit, so it's more like 2 to 1. And if you see over time, there is a slight improvement. We started in 2000 with around 75% of authors being men, whereas now in 2015, it's around 60%. So overall, around 70% of the first authors seems to be men. And if we go into the single author category, this ratio gets quite more unbalanced, 3.29. And as you can see here, the percentage of the proportion of these single authors that are male keeps being the same. However, if we look into our own journal, so animal behavior, these numbers seem much more balanced. We have 58% of first author names being assigned to men. And the single author gender ratio is 1.68. And actually, if we see through time, in 2015, it seems to be almost a 50-50 ratio, which is great. Going forward to this GBI, the overall mean of the dataset is 0.27, so a low male bias groups. And if we look at the distribution, more than 70% is by high or low. male author group, and only 12% are the female biased categories. And there are very slight changes or increases over the years. Again, however, if we look at the Animal Behavior Journal, there is quite a bit of change, and in 2015, there is almost a very balanced distribution of all these categories. So now my next steps is to link these things to citation performance. So what is the effect of the first author's gender or this GBI on reaching a different citation quantile category? Based on the previous analysis that I've done in the biggest category of ecology and evolution, we actually do see a weak negative association between first author having a female name and citation performance. But from a quick look at the data of more specifically on animal behavior seems to not really be the case, but I will know better soon. And I also want to investigate the role of the last author, and especially in combination with that of first author. And I will recollect data from 2000 to reach up to 2020 and see if anything changed within these last 5 years. So a bit on the biases and limitations of also these methods that I'm using. There is quite a bit of discussion in the natural language processing world on gender bias. And of course, the fact that we're inferring gender from the first name is not great. Depending on the language, some languages are indeed gender specific, but others can be completely gender neutral or can even be country dependent. And of course, this category doesn't neglects completely non-binary genders and is really not representative of the spectrum that we have in society. So I don't know what's the way to go around it. I don't know, for example, if introducing gender pronouns inside this metadata information of each paper is in the future can help us get a more clear picture of what is going on. So I don't know if that's a good or a bad idea. And at the same time, the order of authors is very discipline specific often. So in biology, we often have this first to last author connection, but in physics, for instance, it just goes into order of contribution. So the second or the third author might actually be the most senior author supervising, for instance, student that might be the first author. So to work more on that, I'm working with Andrea Fruni from the University of Florence to compare astrophysics, that is a very male-dominated field, with our field of animal behavior to see if we can draw any parallels or help the two fields progress. So again, I don't know if we have any ideas of how to standardize these author contributions more, because often also these data are not really available or they're not easy to extract through these natural language process techniques. So I'm very keen to listen to what you think and if you have any further recommendations for our method before I move forward. Before closing, a shout out to this Equal Opportunity Initiative Fund that I got in 2017. So it's still going on, and it's actually a very cool concept. You can ask for up to 1,000 euros. I think it used to be 1,000 euros to bring to life any kind of project that relates to equal opportunities. And the next deadline is in April, and it's open to any level. So I got it during my master. You can get it as an undergrad or a postdoc or anything. So thank you very much. Please get in touch if you're interested. I'm very happy to discuss more about it, and I also wanted to thank all the professors that supervised me or helped me, supported me while I was doing this project in Imperial College. Thank you.